As the 2023 National Electrical Code nears adoption across the U.S., there are rising concerns amongst manufacturers, contractors, and specifiers regarding the types of changes and additions to the code. While each one of these additions was brought about with the motive of improving safety, not only for our people, but also for our property, it still creates a challenge around understanding what these changes are and how they apply. I'm Kelly Sinovich, and I'm the U.S. Specifier Channel Leader for Schneider Electric. And I'm excited to be here today to host a panel of industry experts on this very topic. Joining me today is Chad Kennedy, our Director of Codes and Standards at Schneider Electric, Judy Robinson, one of our Senior Application Engineers at Schneider Electric, and one of our customers, Doug Keesler. He's the Engineering Manager at Gresham. So Chad, I'm going to start with you. Tell me a little bit about your background, as well as who makes these changes.
Thank you, Kelly. So I'm Chad Kennedy. I've been with Schneider Electric over 30 years. And from the NEC technical committees, I serve on code-making panels 13, 15, and I'm also a member of the NEC Correlating Committee. The NEC is published on a 3-year cycle. Public inputs or revisions to the NEC can be submitted by anyone at nfpa.org. Those first revisions or those public inputs are converted to first revisions by the technical committees based on the topic area. A first revision is then open for public comment, and anyone again can submit public comments on the actions that the code-making panels took. In the 2023 NEC, we had over 4,000 public inputs and nearly 2,000 public comments. So a lot of public input into the new code edition, resulting in over 1,800 first revisions.
We're not going to talk about 1,800 revisions today, right?
Nope. Today we're going to focus on 4 key topics that are important to specifiers.
Fantastic. Doug, I'm going to come to you next. Tell us a little bit about your background and how these code changes impact you as an electrical engineering manager as well as your team.
Okay, great. My name's Doug Keesler. I'm department head of Gresham, the electrical department, for 6 years and have been in the industry for 14. I think these changes really impact the way we're going to look at the design of buildings, space layouts, the additional cost to owners perhaps, and the way we plan these buildings out.
Fantastic. Judy, what about you? I want to hear a little bit about your background, but then also tell us how these changes impact your day-to-day interactions with your customer base.
I'm Judy Robinson. I'm a senior consultant application engineer. Been in the industry almost 30 years, the majority of which has been working with specifiers on their upfront designs. And these code changes are just one of the many challenges that specifiers face. There's just so many things they have to keep up with as the industry is rapidly changing, as we all know. So hopefully our discussion today will clarify what some of the most important changes are and give them some tools to help comply with those.
Thank you. So I think that's exactly what we're going to do today. Let's go ahead and dive into our first topic. That topic is going to be around surge protection. Chad, I know there have been a number of code changes related to surge protection over the last few NEC iterations. Can you walk us through kind of what are those changes, what do they look like, and what is it looking like now in 2023?
Yeah, glad to do it. You know, if we think about the expansion of electronics and digital controls in all areas of our lives, in our homes and in our businesses, we also see this in power equipment. So I think we all have experience on some level of a loss, a product loss due to overvoltage transient and surge protection. So as we look at the 2023 NEC, we'll see that focus, right? In 215.18, we're talking about feeders, and the specific areas that are addressed in this code section are dwellings, guest rooms and guest suites of hotels and motels, dormitory units, and areas of nursing homes and limited care facilities where you have exclusive sleeping areas, okay, patient sleeping areas. When we think about these, it's important to note the location. The new code requirement here requires these SBDs to be located in the equipment or adjacent to the equipment where the overcurrent protection for those branch circuits reside. So it's moving that surge protection closer to those loads that need to be protected, which again, it will provide the most overvoltage protection in that spot. Common configurations, if we think about commercial applications, you end up in many cases with a small panel in each of these units. And based on the location requirement, that's where that surge protective device would be located. Again, placing that protection as close to the units that the areas that need the protection. From a rating standpoint, the surge protection devices need to be either a type 1, suitable for use on the line side of a service disconnect, or type 2, suitable for use on the load side of a service disconnect. In this case, obviously, we would be talking about a type 2 because we're on the load side of the service. But we also have other ratings to consider in this section. We have the rating that the nominal discharge current should be 10 kA or greater. So we have specific location requirements and specific ratings that must apply in this case. When we look at the 2020 NEC, we had a similar requirement introduced there for dwelling unit services, but it was limited to the service. In the 2023 NEC, that change over in Article 230 also expanded to include these areas as well as align the location and ratings. So now they both align. And so Doug, we're talking about feeders here. What about outdoor feeders?
You're right, Chad. So this was added in 225.42 with regards to outdoor feeders and branch circuits for the same types of areas. After considering these requirements, a common question arises is, do we have to install surge protection at the service equipment and the feeder equipment? These two code sections complement each other pretty well. The requirement for service equipment includes an exception for installations where surge protection is provided at each next level of the design distribution. Designing for surge protection that is tiered at each level for the power system will provide a better protection for sensitive electronics, and the code sets the minimum requirement, but not always the best practice.
Yeah, absolutely. I think when we think about those use in the power systems, there's two ratings that we need to keep in mind. One is a short circuit current rating. An SPD does need a short circuit current rating, and that's required for all electrical components in the power system, right? You have to have a short circuit current rating that meets or exceeds the available fault current at that point in the system. And that's all about safely clearing a fault. But the nominal discharge current, in this case 10 kA or greater, applies to how many times a given current can pass through the surge device, the surge protective device, and it remain functional. So in this case, an SPD must tolerate a 10 kA over voltage wave shape 15 times and still remain functional afterwards. So I think it's a key point that both of these markings are marked on the equipment, and it can be confusing for users sometimes to make sure that they recognize both are important. And Judy, you know, when we think about the implementation of SPDs, sometimes we forget about renovation projects or retrofits. How does it apply in those cases?
Yeah, that's a good point. The code does require this to apply to renovations as well. So if you were going to, for instance, replace a panel in a hotel room, for instance, then you would have to add the SPD to that location, which could impact the space and the cost of that project. And as Kelly mentioned earlier, it seems like every code cycle there's some new requirements around surge. So I wanted to touch on an area that I see that's often missed, even though it was added in a previous edition of the code, and that's around 700.8, which requires that all emergency systems, switchgear, switchboards, and panel boards have to have a SPD protection. And just a friendly reminder to our specifiers that they do need to include that. And you know, it seems like these surge requirements are kind of sprinkled throughout the code, so it's just really easy to lose track of where all it's required.
Thank you all for the updates on the surge protection requirements. Speaking of system protection, I understand there's also new requirements around selective coordination. Chad.
Yeah, so selective coordination in this change in 240.11, it's one of those sleeper changes that I think that didn't get a lot of discussion maybe. Maybe it's one of those things that would be easy for folks to miss. So first, selective coordination is a coordination of the overcurrent devices in the power system so that when you have a fault, the overcurrent device closest to the fault is the one that opens and the only one that opens, leaving power on to the majority of the system. And this is particularly important for critical systems, but obviously it's a design practice that I'm sure, Doug, you look for in general designs as well. So where is it required? Well, we have requirements for elevators in Article 620, and we have requirements for critical operations data centers in 645, and emergency systems, legally required standby systems, and so forth. So there are lots of places across the code where this gets pulled in. Let's look at a graphic that'll help us with understanding how this change in 240.11 will impact specifiers. So if we look at the diagram on the screen, you see to the left your traditional normal power bus, and on the right your traditional emergency power bus. And the emergency loads are fed through an emergency transfer switch. And the emergency load is designated by the breaker labeled C in your diagram. Well, traditionally we know that selective coordination is required all the way through that path on the emergency side, all the way to the source. Well, what about on the normal side? Well, selective coordination is required on the normal source, and it's required between that emergency breaker C and the service disconnect service breaker, in this case, breaker A. And sort of we have this big change here now. If we look at the second graphic, that really helps us that all of the breakers at that first level subdivision on the normal side now have to selectively coordinate with the service breaker. So it's not just the feeder, which again, the other articles of the code never really required that to be selectively coordinated. And it's in a strange spot, right? That trigger spot is not with the other requirements for selective coordination. So that normal side is sort of an addition. And Judy, I think that, you know, the example I've given here is dealing with emergency systems, but that may be the easy path. The difficult path might be other applications.
Yeah, Chad, that is a big change, and there are a number of applications impacted by this change. You know, it's tempting to just think about buildings that have an emergency power system using a generator, but let's think about a simple commercial building which uses battery backup for egress lighting. But that same building might have a bank of elevators, and the requirements in 620.62 are going to trigger selective coordination for the elevator feeders with any supply side overcurrent protected devices. So this change now expands the requirement to all those first level feeders at the service equipment. And I think this is a change that's going to be an easy one for specifier to miss because the requirements are located separately from those code requirements which trigger selective coordination. And it's going to likely require some education because it's going to pull in wherever those requirements exist for selective coordination. It's going to require education for owners, developers, and contractors, since this is going to impact things like tenant fit-outs where things are added later and not necessarily with the upfront equipment purchase. Doug, how is this going to impact your work?
This is going to have an impact from an educational standpoint, you know, with specifiers being aware of this change and educating themselves, but also on the contractor side where this requirement hasn't previously been required. So I think it would be our job to kind of bring that to the forefront for the contractors and make it a point so they understand this bidding a job. Enforcement of this code is going to be the key aspect of this requirement. Selective coordination must be performed by a licensed professional engineer or other qualified person. Documentation should be completed, available to the AHJ or the authority having jurisdiction's approval. And it's important to note that these requirements can vary by jurisdiction, and you need to know those up front so you don't get yourself in trouble later. It's important to emphasize that this requirement doesn't directly impact healthcare facility designs, since this code requirement for healthcare facilities requires coordination, which is different from selective coordination.
Yes.
This change will not impact the essential electrical system for healthcare facilities. However, it could affect other buildings on a healthcare campus.
Yeah.
So specifically from a design engineer perspective, what challenges is this code change gonna make for your employees?
Well, coordinating or selective coordination at higher fault currents can make it very challenging. So I could see this driving equipment size larger, frame size of breakers, causing trip units to be electronic trip, causing more cost to the owner in the upfront case where this hasn't typically been required. So specifiers are going to need to be aware of the types of buildings they're designing to make sure they can differentiate whether coordination or selective coordination is required in this application. During the design stage, engineers do not often know which switchgear manufacturer will be the successful winner. So I would encourage specifiers to partner early with vendors so they can space plan accordingly.
That's great, Doug. Schneider Electric has a team of application engineers and in our sales offices and on call who can assist with making those breaker selections. We also have an online selective coordination analysis tool, and in some cases a preliminary coordination study may even be required. ETAP software, which recently became part of the Schneider Electric family, can be used for this type of analysis.
Fantastic. So expanding upon the discussion of the code changes that are impacting critical systems, How important is it that these systems are set up so that we know that they're ready to perform when called upon, Chad?
Yeah, that's a great point. In 700.3, so we're in emergency systems, we have a new requirement for commissioning. And I think it speaks volumes to the complexity of modern power systems. But in this new requirement, the AHJ must conduct or witness the commissioning of the power system, the emergency power system, and approve any type of periodic rescheduling of testing. So I think it's an important step forward. And Doug, maybe you want to speak to how commissioning differs from just normal tests that might be performed on an emergency system.
Yeah, it's funny you mentioned system. So when previously to the code and previous revisions, it would only require testing on specific components for their operation and didn't look at the entire system testing. So I think commissioning is really going to go well beyond making sure individual components work. So it's going to go into the sequence of operations of the equipment. You're going to be assured that your entire emergency power system is operational versus the individual pieces. You want to see those operate as a system together. So it's going to look at your sequence of operations. It's going to look at breaker settings. And the commissioning agent is going to validate and verify the design intent is followed. And they're following the engineer of records contract documents, the owner's project requirements, and more importantly, they're getting the system that they were promised at design. The more holistic approach to evaluating the essential power system, I think it's going to be seen as an overall improvement to the process.
Yeah, it's interesting because now emergency systems are getting a lot more complex. We're seeing additional on-site generator options such as microgrids and energy storage, fuel cells. So the importance of complete commissioning is enhanced with this additional complexity and the control systems that are associated with these sources. Are there instances where the setting of overcurrent protection doesn't happen, and does this new code requirement address those instances?
I'm sure there's instances where breaker settings have not been checked or not been verified, but I think overall the change in this process and this code requirement is going to improve that, and I think going to be a lot less cases where that's going to be the case.
I think from a big picture standpoint, part of this change not only includes that documentation of commissioning, but also maintenance records, right? And so I think from a big picture, we're seeing how the NEC, NFPA 70 and 70B and 70E now all fit together. So we have 3 standards: workplace practices for electrical workers, we have a standard for electrical equipment maintenance, and we see how all these fit together. And part of that is making sure that your emergency system, these critical systems that need to be commissioned, are also reliable. And that goes with that first step, is that initial installation in compliance with the code and commissioning. So Judy, how can Schneider Electric help customers with this whole commissioning topic?
Sure, yes, Schneider Electric can definitely help with commissioning. We have service engineers who can assist with the initial commissioning, and then we also have software tools and equipment options that can support this effort by providing system and equipment health information, such as real-time data, temperature measurements, and couple these into analytics to determine specific maintenance schedules. So you're not just doing annual maintenance or periodic maintenance, you can actually do maintenance when the equipment needs to be maintained. So this system commissioning, along with the periodic system performance testing, can provide the best reliability for these systems.
So let's move on to our next important topic of these code changes, and that is one that impacts the potential size of the electrical room. And this one's important because we know that 30% of the construction cost today is related to change orders, and most specifically around this code standard. So Chad, can you kind of explain what changes have been made in the 2023 edition and how that's going to impact the working space required?
No, thank you, Kelly, because 110.26 is the section that we're talking about for working space. And this code change really, I think, is really important because it solves a long-standing concern over how open equipment doors can impact the working space, entrance and egress out of the space. We've had a requirement in the code that the equipment doors open a minimum of 90 degrees. And this really goes beyond that to say, well, okay, how much working space do I need? And this clarifies that you need a minimum of 2 feet or 24 inches wide by 6.5 feet high entrance and egress out of the working space. And I think that's a really key component that was really left subjectively up to AHJs to interpret, do you have enough working space or not? So we have a couple graphics that'll help us walk through this code change. So if we look at the graphic on 11026, we see an equipment lineup, and opposite the equipment lineup, we have our working space line there, our drawing there. And if we think about where that line is, if that was a concrete wall, then that could be considered a condition 2 space in accordance with table 11026, which means that you need 3.5 feet or 42 inches of working space. And if we consider large equipment, because large equipment would have the largest doors, so a 480 volt switchboard in this case, let's consider a 30-inch door. If that door will open to 120 degrees, now it protrudes into that working space 26 inches, therefore really only leaving 16 inches of entrance and egress out of that working space, which now we know is not enough, right? We have clear delineation. So that electrical room's got to get bigger, right? So I think that that's a key thing for folks to consider. And they're going to need to include that in their layouts, right, to make sure that they can accomplish that. A common question that gets asked, though, is how does this get impacted if I have multiple lineups and the multiple lineups face each other? Well, if we look at our second graphic, we can see a lineups where an electrical room with a common configuration where the equipment lineups face each other, right? And now we must consider equipment doors open to their maximum position in both lineups, and whether or not you still have that minimum 2 feet wide working space, depth, as well as the height to get out of that room. So I think that in total, this is a really positive change. It removes some ambiguity on the requirements. And so I think that it's an important change to go forward. Judy, when we think about door openings and the equipment, where are customers going to get that information?
Yeah, they're probably going to just need to contact the equipment manufacturers, because we can provide that information to them. But they also need to think about the physical constraints of the actual room. In some cases, even though our doors will open wider than 90 degrees, it might be mounted next to a wall and not allow the full door opening. So they're going to have to pay close attention to details like that.
Thanks, Judy. This change will highlight the need for architects and engineers to coordinate space requirements. Once construction is in place, it can be very costly or difficult to solve these problems. Additionally, the new requirement in this section requires proper grading for the working space along the depth and the width of it. And this can be particularly challenging in an exterior application with gear. So, Judy, does Schneider Electric offer any tools to assist with this?
Yeah, there's BIM tools such as Revit coupled with our advanced electrical design can help specifiers manage these requirements during the design stage.
So it seems like there's been subtle changes around the working space in the last few cycles of the NEC. So this has all been great information, but since we have a few minutes left, I want to touch on a topic that's near and dear to those of us at Schneider. And that's around sustainability and building management systems and the new energy landscape. So Chad, what code changes were implemented in the 2023 cycle that impacts this even further?
That's a great question. I think we all kind of have input here, but in the energy management space, big changes were made in the 2023 NEC, where now we've moved beyond our building management systems that maybe just do monitoring of systems to help you comply with the energy code or a high performance building code, that now we moved into energy management can control not only loads, but actually control sources. And I think that's a big space when we start thinking about all the applications where that might fit for microgrids, energy storage. But there was also a higher level change where now the energy management system can impact the size of your electrical infrastructure. We had a changeover in Article 220, 22070 that now lets your energy management system impact your load calculation for the building. So if we think about all the ramifications about that, it's a big change. But I think if we see we're moving beyond just monitoring and control to now a system that operates, that it can incorporate a very simple system to a very complex system. And I think all of that fits in the energy management system umbrella.
So Doug, one thing that I've learned recently is that more than 65% of your end user customers have KPIs around meeting their sustainability ambitions. So how are these code changes and the fact that your end users, this is very important to them today, how is this impacting you?
We get the requests from owners quite a bit to explore sustainable options, whether that's the use of fuel cells or solar, wind, any other renewable sources they can find. And eventually they become cost prohibitive to the project. And I think with the introduction of energy management systems and the ability to control these, limit your loads, I think it opens new doors for clients to do partial installations for some of these and add on to them later. So I think I'm excited for the future of the landscape of energy management systems and look forward to the challenges they present.
And Judy, specifically from you, are you getting inquiries from your customer base around sustainability and the new energy landscape, and how are you addressing those?
Yeah, we're definitely getting a lot more inquiries coming in for PV and energy storage systems and that sort of thing. So it's definitely a lot of changes in the works, and you know, we're looking forward to the challenge of supporting the specifiers as they forge this new territory.
Yes, it's definitely an important topic, and while there may be some added cost up front, it's one that they would definitely have a substantial ROI for future. So before we wrap our panel today, are there any final thoughts? Doug, would you like to add anything?
Yeah, thanks for having me here, and I appreciate the opportunity to be in here. Thanks.
Thanks for
We
coming.
really appreciate you joining us.
Yes, we do.
Thank you to both Doug, Judy, and Chad for all of this informative information. If you're looking for more information on codes and standards and looking to educate yourself on the 1,800 changes that were part of the 2023 NEC edition, please visit our codes and standards page on SE.com.